under the surface of our oceans rests a world we were never supposed to discover. A realm where brightness dies and existence bends into forms that defy logic. As we push downward from the bright shallows to the dim twilight and into total darkness, the creatures around us become ever more unsettling. We've landed machines on Mars. We've charted galaxies millions of light years away. But the deep sea itself is still a mystery, over 95% untouched by human eyes. We understand the moon's landscape better than what lies just 6,000 feet beneath our own oceans. At the ocean's surface, everything feels alive. Bright waters, bustling fish, and an entire web of creatures powered by sunlight. Plankton thrive in the glow, feeding fish, which feed reefs, and eventually, giants like whales. But slip past 200 meters and that light starts to dissolve. You're entering the twilight zone, a dim, endless band of sea that sinks nearly a kilometer down. Here, sunlight is too weak to fuel life the way it does above. The rich green forests of plankton disappear. Plants vanish. Photosynthesis stops. Instead, life survives on a slow, constant drizzle of debris falling from the world above. Tiny particles, bits of plankton waste, fragments of things that once lived. Scientists call this marine snow. To us, it looks like dust. But down here, it's the only thing keeping life alive. And where there is food, something always adapts to eat it, just not in forms we'd recognize. The creatures of the Twilight Zone have twisted themselves into shapes that look more alien than earthly. Many are see-through, as if made from glass. The glass squid floats like a spirit, its organs faint silhouettes in the blue. The glass octopus is almost entirely invisible. Only its eyes give away that it's even there at all. Why so many creatures turn transparent down here is something scientists still haven't fully solved. Maybe it's camouflage, an attempt to dissolve into the faintest remaining glow. Or maybe it's pure efficiency, saving energy where every pigment is a cost the body can't afford. Yet, not all life chooses invisibility. Some do the opposite. They shine. In this dim world, certain species generate their own light through a chemical process called bioluminescence. To us, it's breathtaking. Pulsing sparks, glowing bodies, tiny lanterns drifting through blackness. But down here, light is a weapon. Some use it to lure prey, some to signal mates, and some use it to vanish. This vanishing act has a name: counter-illumination. From below, predators see silhouettes against the faint shimmer above. To erase that outline, animals like the firefly squid light up their undersides with tiny glowing organs, adjusting the brightness until their bodies match the glow overhead. It's camouflage by imitation, creating light in order to disappear into light. Other species play stranger optical tricks. The bloody belly comb jelly glows in deep red, a color that never reaches these depths. Down here, red doesn't exist, so the jelly appears pitch black. Inside, anything it eats stays hidden, even if the prey itself gives off bioluminescent light. It's nature's way of hiding your meal inside a curtain of darkness. In a world ruled by light, or by the total absence of it, every adaptation is about visibility. Who can be seen, and who stays invisible. But the Twilight Zone holds more than clever disguises. Every night, as the surface grows dark, billions of animals surge upward. Lanternfish, squid, jellies, an entire army rising under the cover of night to feed on plankton. At sunrise, they retreat again, melting back into the shadows. This nightly ascent is called the vertical migration, the greatest synchronized movement of life on Earth. Larger than all the herds on land, more massive than all flocks or swarms combined. And astonishingly, humanity only discovered it during the World War II, when naval sonar picked up what looked like a moving seafloor, an enormous layer that rose each night, then sank again with the dawn. Not terrain, not rock, life. A hidden world traveling together. The Twilight Zone is where the rules of survival start to twist, where being clear is armor, where shining lights can make you disappear, where billions rise and fall in an ancient rhythm older than humanity itself. Below a kilometer, the last trace of sunlight dies. You've reached the midnight zone, stretching down nearly 4,000 meters. Here, there is no morning or evening, only unending black. The temperature hovers just above freezing. The pressure crushes with hundreds of times the force we feel at the surface. To us, it seems impossible that anything could exist here. And yet, evolution becomes its most imaginative in this eternal night. Consider the dragonfish. While most deep-sea animals can't see or use red light, this predator produces red bioluminescence, its own invisible flashlight. It reveals prey without exposing itself. Even stranger, the dragonfish's eyes have evolved to detect this hidden color. It's like it invented a private wavelength only it can use. Other hunters rely on invisibility of another kind. Some species are coated in ultra-black skin, absorbing almost every particle of light. So dark, they reflect less than 0.5% of it. Even under a submersible spotlight, they barely exist. And then, there is the anglerfish, perhaps the most bizarre predator this abyss has ever produced. The female anglerfish dangles a glowing bait in front of her mouth, tempting anything curious enough to come close. But her greatest oddity isn't how she hunts, it's how she reproduces. Males hatch tiny, fragile, and nearly useless. Their only purpose is to locate a female somewhere in the endless dark. When one finally does, he bites into her and never lets go. His body slowly merges with hers, his organs shrink away, and he becomes a living attachment. Nothing more than a source of sperm, sustained by her bloodstream. It's one of nature's most extreme mating strategies. But down here, not everything stalks and hunts. Some creatures wait. Scavengers bide their time for whatever falls from above. A single whale sinking to these depths becomes a banquet, sustaining entire communities for decades. And even with submersibles, our understanding of this realm is patchy at best. For every species we've recorded, scientists believe there are dozens still unknown. Every dive into the midnight zone reveals forms new to science. Creatures with shimmering eyes, needle-sharp jaws, or bodies so delicate they collapse the moment they're brought to the surface. This is the midnight zone, a kingdom where light becomes a weapon, where invisibility is a shield, and where even reproduction defies imagination. 4 kilometers down, the open water finally gives way to the seafloor. We reach the abyssal plain, one of Earth's largest habitats, covering more than half the planet. Yet it is also one of the least understood. Here, the world is flat and featureless. No reefs, no forests, no mountains, only a wide desert of fine sediment stretching for thousands of kilometers. Temperatures never rise above 4 degrees Celsius. Food is scarce. Survival demands extraordinary adaptations. One adaptation is size. Many abyssal animals are giants compared to their shallow water relatives. Giant isopods, large as puppies, crawl over the mud. Amphipods can reach the length of a human hand. Even the colossal squid is believed to roam these waters. Scientists call this phenomenon deep-sea gigantism, but its cause remains uncertain. Some suggest it saves energy. Others think it deters predators. The truth remains elusive. Another rare feast arrives when giants from the surface fall. A whale corpse becomes a treasure. Within hours, scavengers converge. Sharks, hagfish, amphipods. Then stranger organisms arrive, bone-eating worms that drill into the skeleton, extracting oils locked within. An entire ecosystem flourishes from a single carcass, feeding for decades until only dust remains. Other creatures get by with far humbler meals. The vampire squid, despite its ominous name, doesn't hunt at all. It collects drifting particles of marine snow using long, sticky threads. Even in low oxygen waters, it thrives thanks to a blood pigment with the highest oxygen-carrying ability known in any cephalopod. Here, life moves slowly. Growth is gradual. Reproduction infrequent. Lifespans stretch into centuries. The Greenland shark, which can inhabit these depths, may live more than 400 years. The longest-lived vertebrate ever discovered. Down here, even time seems to slow. Yet the abyss is not lifeless. Every grain of sediment hides countless microbes recycling nutrients and sustaining an invisible food web we're only beginning to understand. The abyssal plains remind us of the planet's magnitude, larger than all forests, plains, and deserts combined, yet still largely unseen, unexplored, and unexplained. Beyond this plain lies an even deeper frontier, the ocean trenches carved by tectonic forces. These are Earth's scars, places where one plate plunges beneath another, dragging the seafloor downward into unimaginable depths. This is the Hadal Zone, named after Hades, the realm of the dead. It begins around 6,000 meters and descends to nearly 11,000 meters, the deepest known point on Earth. Imagine dropping Mount Everest into the Mariana Trench. Its summit would still be more than a mile underwater. Conditions here stretch the limits of comprehension. Temperatures cling near freezing. Pressures can exceed 1,000 times those at the surface, instantly lethal to the human body. And yet, life here not only persists, it flourishes. Among the most astonishing are the snailfish that inhabit the very bottom of trenches. Soft, ghostly, and nearly transparent, they seem far too delicate to endure such force. Yet they are the deepest living vertebrates ever discovered, thriving where no other fish can. Their bodies have no rigid bones, and their cells contain special molecules that keep their proteins functional under immense pressure. Other residents are smaller, but no less remarkable. Amphipods, shrimp-like creatures, swarm across the trench floor in astonishing numbers. Recent research has revealed plastic fibers inside some of these trench-dwelling animals, clear evidence that even the most remote places on Earth aren't untouched by human waste. It's a sobering reminder that the deep sea is not as isolated as we once imagined. At hydrothermal vents scattered along the trench walls, life becomes stranger still. Here, microscopic organisms survive not on sunlight or falling debris, but on chemicals bursting from the Earth's crust. Hydrogen sulfide, methane, and even metals dissolved in boiling water. Entire populations of worms, clams, and crabs depend on these microbes. A food chain built on chemistry instead of light, proof that life can thrive in environments utterly alien to anything on the surface. And that raises a larger question. If life can adapt to extremes here, could it not do the same elsewhere? Moons like Europa and Enceladus hide oceans beneath ice, warmed not by sunlight, but by internal heat. Studying the Hadal Zone is like glimpsing what oceans on distant worlds might look like. Yet despite its importance, our knowledge of the trenches is almost non-existent. Fewer people have plunged into the Mariana Trench than have walked on the moon. Every descent returns with organisms new to science. Translucent sea cucumbers drifting like parachutes. Amorphous blobs with no obvious organs. Microbes running metabolisms we don't understand. For centuries, we pictured the trenches as barren voids, silent graves at the bottom of the sea. But what we've discovered instead is resilience. Life that reshapes itself to endure unimaginable pressure. Even now, more than 80% of the ocean remains unexplored. Every ROV mission brings back forms no one predicted. Transparent fishes, luminous worms, jellies that seem to ignore every rule in biology. Down here, discovery isn't rare, it's constant. And among the species we already know, questions pile up. Why do so many grow to enormous proportions? The giant isopods, the colossal squid, the amphipods stretching the length of a human hand. Why do others become almost invisible or cloak themselves in ultra-black skin that eats nearly all light? And then there's bioluminescence, the greatest mystery of all. Nearly 3/4 of deep-sea life glows, yet for wildly different reasons. Hunting, hiding, signaling mates, or perhaps something we haven't guessed. We still don't fully understand how these chemical light systems evolved, or why some creatures shine in wavelengths no other animal can perceive. Deeper puzzles wait still. For now, they remain unanswered. Perhaps that's what makes the deep sea so powerful. The reminder that our planet is still filled with secrets. Secrets worth searching for and protecting. We know more about the surface of the moon than we do about what's happening 6,000 feet below our own oceans. And the little we have seen is just the beginning. Subscribe now for Discover More.